This call is now being recorded.
So, good morning, all, and thanks for joining our webinar. Um, Welcome you to the fourth episode of application modernization or application containerization. I'm Deepak and have been with you in last a few sessions as well. And I'm sure you will have a great time. We have packed it for 120 minute. Or most of our these workshops are 2 hours at least. So please organize yourself. Be on mute when you are not speaking. These are certain ground rule in the forum. Use the chat to ask questions. Do not hesitate, don't hold yourself. Please speak up and ask questions. During the workshop, what we are going to do is we are going to discuss quite a lot of stuff today, and I'm sure it is going to be very, very interesting and exciting for you, especially when we will talk about some application related stuff. So today we will talk about um, why DevOps, why an organization require Kubernetes or OpenShift, and um, beyond OpenShift, we will talk about application developers. I'm sure many would have joined as application developers. If you're an application developer, say yes on the chat so that we know what kind of audience we have. So we will talk about microservice approach, microservice standards, and what makes anything as a microservice. The best practices we will discuss. We'll discuss how organizations have evolved with respect to the microservice and how you can architect your application for microservice. And now when you are running microservice, how OpenShift is bringing the um, qualities, right? Okay, with respect to the observability, with respect to the distributed architecture, with respect to traffic control, how different kind of deployments are helpful, so we will be talking and how you can make an application fault tolerant, so that the catastrophic failures can be limited or reduced. So we will talk about those scenarios, and I will have some of my colleagues or co-presenters who always help for the demo, because they manage, maintain the lab, and they are always on the project. So I'll be taking their help. So this time I have one of my colleague from Singapore. He has joined, and let me introduce my colleague as well. So as usual, this is a picture of mine with Randy. Randy have been an inspiration for me since I started exploring Linux and open source back in 2003. And I happen to work extensively with Randy in the training space, and he is the current director in Red Hat for Global Learning Services. And the other picture, I could not get a better picture of Chandra, but that's Chandra, who's my solution architect, and he's a colleague of mine in Singapore. And Chandra is young, that you can guess from his picture, but at the same time, okay, he's very energetic and very technical with respect to the application DevOps and Kubernetes. So we will have Chandra, and as usual, Ajay, Udit, some of them have also joined. So I will have their help as well. So We have a good panel today, so do not hesitate, to ask your questions, and um, anything related to the topic, please don't hesitate. Okay, uh, so I will, get into the application first. And as the agenda says that, okay, we will talk about the application, and this is going to be this is going to be an application related session. Um, I will, I'll better uh, take you to um, another page. Let me see. Sorry, guys. So I thought, okay, I will take you to some level of learning which is required before I get into the applications. So let me just, yeah, here you go. Okay. Too much of content to go right. Hmm. So so let's talk about the application first. Nevertheless, so before we get there, how do you interpret a monolithic application? If you have any points, to talk about monolithic application, please speak up. Don't hesitate. The monolithic applications are especially or primarily, designed as a Java application. So let's take Java as a standard here, right? And if you have taken a monolithic application, I'm sure you must be having some level of what do you call complexity which you have brought into the application, right? Means and If you look at the industry, everyone in the industry is becoming an try to become a unicorn in Silicon Valley, right, or in Bangalore, because I'm sure a lot of you have been here, wanted to be a microservice developer, and that's the unicorn which you are trying to become, right? But what you have developed is an application which is monolith, and that particular monolith application has a certain architectural style. It is a very large service. I'm not sure, okay, if you have understood the evolution of an application, but let's talk about that. So think of your organization. How long you can use the chat and talk to me. How long does it take to make an application goes live, right? Please put it on the chat. How long your organization take the application live? Okay. If you have understood your organization release process, okay, I'm sure you would appreciate that. Okay, so please put it on the chat. How long does it take? Does it take 1 month, 4 weeks, or does it take 3 weeks? Does it take 6 months, or it takes 1 year, right? Because that matters the most, right? How long does it take to take your application live? And the reason what you have built, and why does it take that long to go live? There is certain dependency, right? And that dependency is due to your organizational process. Okay. So what happens? You have an enterprise architect team, you have the project management team, you must be having a sponsor who gets the budget, and I'm sure you must be getting the requirement, continuous requirement, onto the project. And what you're developing an application which is a monolithic system, and that particular monolithic system, it takes, uh, on an average, I'm talking about, uh, 12 weeks, right? So 12 weeks before an application get to see the feedback from the end customer or the internal employees about the application. So that is the current state. Okay. Do you agree to this? Say yes. If you don't, you already have an organization where it takes several deployments in a day, that also you let us know. Okay. Because we are here to discuss the best practices. So uh, so in those kind of scenarios, why does it take average 3 weeks, right? When you have built a monolithic application, it takes 12 weeks. It takes 12 weeks because a sprint, if you understand the sprint model, uh, ideally the sprints are like a couple of weeks size sprint, and each sprint has certain thing to do, right? For example, you take first three sprint to develop, and second sprint to make sure that okay, you get it um, containerized, or you make the build and containerize. Then you deliver, create a CI/CD pipeline. Then you do the deployment. Then it comes for the feedback. So no matter whether you run an application on a VM or run an application as a container, it is taking 12 weeks. Okay, so around 4 to 6 sprints to get your application the first feedback. And that is the regular practice in most of the organization. Okay, and the organizations where I have worked, I can give you that confidence that yes, most of the organization have been on that practice. Have that changed? Answer is yes and no. Reason is, in enterprise, the large organizations, these environments are very high trust environments, and no system operation folks will allow you to uh, accept the failure. And when you don't accept the failure in the organization, they always try to do things on a on a preferred way, which it takes time, right? So that is why applications getting delivered, the first feedback is it takes about 12 weeks. That's the problem statement today. Can we change? Answer is yes, we can change. And today we will discuss how that change can happen. Okay. And what is the target state we want to achieve? We would like to achieve at least 8 to 10, or 10 to 50 deployments in a day. That means your development culture is changing from few deployment in a month, or in 12 weeks, to uh, 10 to 12 deployments in a day. So that cultural change, if you want to bring in your application development, then we are talking about microservices. Okay. So first is the business, right? The business reason I gave you: the time, budget, complexity, trust. These are the reason which let the developers develop something, and it takes longer to get the feedback, right? Now, if you have understood that the business want you to do more frequent deployments, and they always trust you and say that yes, if something fails, you can roll back, and it is not creating any user experience impact, uh, then that is one reason, okay, where you can introduce microservice. The second aspect of microservices, when you are on the development path, can you divide the complete application onto smaller services? What you see is that, right? What you see is, you have got several services bundled or part of one application, right? uh, so each service has a function or has a role to play, right? I'm sure you'd agree that each of these service in this picture has certain role to play, right? And each service um, are talking to each other because they are expected to talk to each other, right? So they are expected to talk to each other here, right? And when they are expected to talk to each other, that is nothing but network of services. Okay, so how does that network of services means? um, by now, I think on the first session what we did, we talked about the definition of a container, right, or definition of an application. Operating system, you have got JVM, you have got a service or certain functionality built into that JVM, and that becomes your application. But now we are talking about service. So I will say a container, which is a baked container image, has a application deployed. So it's a running process, and it has a service embedded to it. So if each is a service, service A talk to service B talk to service C talks to service D, right? Then this kind of scenario you'd be expecting, right? So what does that mean? Microservice is always on distributed computing. Uh, any organization deployment you would look at, the service A, service B, service C, or any number of services, they back and forth talk to each other. Can you guarantee that these services are all hosted in the same Linux machine? Answer is no. It is expected to be distributed computing. That means a service is talking to the other service, not necessarily on the same machine. It is on another worker node or another machine. So the service is talking to another service, and this particular service communication is definitely going to take time, and there is certain latency or some dependency is expected. When that kind of dependency is expected, that boils down to your microservice fundamentals or the topics which influence the microservice. Okay, I'll talk about that as well. So all that what you see in here, right? Okay, these are the qualities of microservice which actually influence the microservice architecture, right? So whether you have discovery, invocation, elasticity, any of these, right? Please understand that each of these are, if you calculate 3 3 6 3 9 10, so there are 10 factors here which is actually influencing the microservice architecture, right? So what does that mean? Each has a certain functionality to play. For example, let's talk about um, elasticity. Elasticity means you have services should scale, right? Let us talk about monitoring. So you have the service monitoring, or let us say you talk about um, config management, decouple, or dependency to resolve. So each of these criteria, so not just these 10 what you see here, you must have less dependency, you must have must not have a file system implication, you must have a language or library issues, the portability. So these are the qualities which actually make the microservice powerful. Now, how the history has influenced, right? If you can go on mute, uh, whoever is not speaking. So if you look at the history, many of you must be thinking that, okay, this is something, a subject, which is very recent, right? No, this is not something which is very recent. The first, implementation of microservice, I would say, was, from Netflix. But who took the courageous step? If you look at the evolution of the services, so since 1999, the continuous integration was brought in, the agile, way of software development. So the 12-week one, or 12-month one, what we talked about, that is the waterfall model. The agile software development is since early 2000, right? Um, AWS EC2, which allowed you to adopt virtualization on cloud, where the trusted environment which you talk, can it be provisioned in minutes or within an hour? That started happening in 2006, not in last year. Similarly, the DevOps, it's been there since 2009, right? So can the Phoenix project, whatever you talk. Netflix is the first company which took the consumer services, right, the entertainment services to AWS in 2010. So that means it was very much known to the market that we are taking the services to a cloud infrastructure where changes are frequent, and this is going to be the disruption in the application development, right? Today, we are on Kubernetes, we want to run applications on Kubernetes or OpenShift, right? So history wise, this is not something which is yesterday's story. This is something which have been there for at least more than decade, and you should not have a problem of what do you call, not knowing how you will organize your services. Now, we have understood the service, we have understood the qualities of the service, right? The qualities of the services are these 10 qualities. Now, a service which is of that enterprise standard must have these qualities. Then what will you do? You will bake these services onto that container, right? So these qualities onto the container. So that means a service A is going to have discovery, load balanced, scalable, metrics, tracing, resilient, all that, right? So you're making the service whole lot of features into that, because each service is having those qualities, right? So that becomes my next problem statement, right? So today we are here to discuss not why containerization. I think we have already discussed that, right? But today we are here to discuss how you can organize your application development services, right? Now, the next topic here is how each of these can be achieved. Each of these can be achieved if you are taking OpenShift and Kubernetes, right? You can achieve discovery, invocation, elasticity, right? You need not have each service. You can have the control plane to take care of that, right? And you can have monitoring, logging, pipelining, that kind of thing taken care by OpenShift, right? So when you have uh, Kubernetes and OpenShift is taking care of several of these things, then I would bring the next disruption, that is nothing but this service mesh. Okay, as you know, the the Kubernetes term, right? Um, and Istio, which is the service mesh technology. So these are all related to the ship sailing, right? So Istio is as the symbol says that, okay, your service should function no matter what goes behind the scene or what happens behind the scene, right? So what we have understood is that, okay, over a period of time, when you are on microservice development and you are thinking of the disruption, the definition of microservice is definitely touching the Istio, and that is making the microservice not getting impacted when a service fail. I still can take you to that diagram. Just think of this, right? This is a mess, and when one particular service fails, right, what would happen? It'll create a catastrophic impact on the service delivery or of for the consumer not accessing or not able to access. And you all understand that when something is not working, what do? You keep refresh, keep refresh the browser. So already a service is down or it is dead, and you are hitting the dead service again and again and again, and making that job difficult for the developer. So for the developers to get rescued, uh, the service mesh definition, what it says is, it's a tool which brings observability, security, reliability to the application. By bringing these features onto the application, right, onto the application services, and making sure that it is not increasing latency, not increasing latency and not creating a catastrophic impact, then that particular technology is, or the term I would call as sidecar, right? So the application, which was a microservice already, and there are several microservices. Each microservice has got definite expected features which need to be incorporated in the development style, and make sure that it is not becoming heavy, and it is not becoming slow, and it is not becoming a bottleneck in the cloud native environment, and it is not creating a catastrophic impact on the user experience. Then service mesh is bringing observability, security, and reliability, right? So these are the three things which it is bringing to the table, and that is why we will be spending some time today, right? We'll be spending some time today to demonstrate how each of these things work. Okay, please stay on. Whatever we are talking, we will be demonstrating today in front of you how it works. Okay, I'll just pause here if there are any questions.
Hey Deepak, am I audible?
Yep.
So, Deepak, one of the things you mentioned, in one of the slides was a concept called elasticity. How would you differentiate elasticity and scalability?
Very good. So if you are talking about scalability of what?
Scalability of a microservice.
Scalability of a microservice. Do you want to solve it programmatically or by the environment?
By the environment would be the ideal approach.
Exactly, and that is what OpenShift brings.
Right.
Right,
Okay.
that is
Yep.
what uh, OpenShift brings, that you are getting what you want to achieve without you go and manually scale it, right?
Right.
I believe that is what you wanted to convey, right? Okay, when your workload increases, right? So why these companies, the most popular consumer companies, which is dealing with customer experience, and they expect um, hundreds, thousands of hits any given point of time, right? And that to be achieved, that means when the workload increases, okay, so there is a static increase of the workload, and that gives you the elasticity. So increasing scalability through elasticity. Did that answer? Means,
Yep.
did I answer that question, or you
Yep. Yep.
have another perspective to explain?
No, that's really important. Thank you.
Okay. Okay. So if we all are comfortable, right? So what did we achieve? So all the 10 features which we wanted to achieve in an application, microservice. So how do we solve the problem? First, we understood the delivery cycle, the cycle time, 12 weeks, from 12 weeks to at least 10 deployments per day. I repeat, from 12 weeks of release to at least 10 deployments per day. That means you are not worried about when the deployment happens, will there be a downtime or not. You are not supposed to hit that downtime, because when you're doing the deployment, how will you do the deployment? Okay, whether you will do AB, blue green, or any other kind of deployment, right? So we will talk about that also. So when your deployments are happening to a particular service, not the whole application is not getting replaced, right? Then you should not worry about your deployment, right? So from one release in 3 months to 10 deployments or 10 releases in a day, right? If you want to achieve that, or 50 deployments in a day, or 500 deployments per day, if you want to achieve that, then you need to have this kind of solution, right? So who will take care of what? That I have distributed already, right? Who will take care of what? That we have already distributed. So how is it solving the problem? Your application which you were developing on Kubernetes or on OpenShift without Istio was like this, right? Now what Istio is bringing? Istio is bringing the capability of, I said, resiliency, discoverability, as well as the the top qualities of Istio, which I talked about, right? Observability, security, resiliency, right? Reliability. So if you are bringing those qualities onto Istio, and what Kubernetes was already doing and what OpenShift is already doing, if you combine them, then this is how it should look like. So your service is now having another, within the pod. As you know, Kubernetes and OpenShift work in a pod structure. It is carrying a container called Sidecar Container, right? So the Sidecar Container is the qualitative measure, where it is taking care of lot of that expectation what you wanted to solve through the program, right? So having certain things not to fail, okay, and taking care of network communication, bringing a control plane, is actually done by the Sidecar Container. Anyone wants to add anything here? guys?
There's probably one more architecture slide which delves into it a bit more. Probably we can touch up over there on why and the other components of service mesh.
Okay, sure. And um, any other points? Okay,
Nothing as of now.
so I will take you to Istio. This is what you're referring.
Correct.
Yeah. So would you like to talk about this?
Sure. So one thing to sort of understand here is the fact that the end goal is not to really change the way applications talk to each other. At the
Yeah.
end of the day, we want to ensure that whatever communication protocols that the developers are comfortable with leveraging, they would continue to do so. So that ranges all the way from HTTP API requests to gRPC or TCP-based socket communication between the microservices itself. So the lines that you see, which are actually being used to convey the communication, that is showing the same thing, right? At the end of the day, you can use whatever communication protocol you want to use. Now, like Deepak has mentioned, the thought process behind a service mesh is how do I actually enable these microservices to know how to reach that endpoint, right? Or the service to service based communication, how is that actually going to be routed? So that is the challenge that the service mesh is trying to solve there. So the containers that you see in each of these pods, the ones at the bottom, the Envoy sidecar. So that is the actual component which is responsible for holding those rules to, perform that communication itself. Now, uh, the question becomes how does that end up getting the rules itself, right? So that is where your mixer comes into the equation, the Istio mixer that you see. So that is the essential brain which is responsible for providing those rules to these sidecar containers. Uh, Pilot and Auth are more of auxiliary services. So the Istio Pilot is more about sort of enabling the sidecar proxy containers, allowing you to execute certain rules and policies to them. And Auth is obviously when you have the HTTP based communication through API calls. You will have some CA certs to be exchanged between these services. So that is the one actually responsible for holding all that information. So your actual brain there is the Istio mixer, which is supplying the rules to the sidecar containers. And then you have the sidecar containers actually doing the routing between the pods. So now you might ask me, hey, all this sounds very complicated. How does how does it actually work in the backend, right? The answer is quite straightforward. It's essentially just IP table rules. So the beauty of Kubernetes and the auxiliary services that come along with it is the fact that they utilize very simple, frameworks, underlying frameworks to actually enable this overall orchestration. So when your Envoy sidecar container, essentially at the end of the day, boils down to using IP table rules to enable this communication.
Okay, so I'll thanks Chandra, and like a pilot, uh, Istio is driving the microservice ships ship with thousands of microservices seamlessly. So I'll let people ask questions if they need need anything to be clarified with respect to the um, service mesh, right? Means, or in one line you can say next generation microservice. What did I say? Microservice is not yesterday's term, right? Okay, it has been there for many years, but if you are on the next generation microservice, then service mesh.
May I ask two questions, not directly related?
Okay.
First thing is, do you? I need an example of a scenario where a microservice-based architecture may not be the right thing. What I'm trying to ask is where you may still think container is the best thing. And sorry, not container, the VM is the best thing. And second thing I
Mhm.
want to ask is, all those things are actually coming from a point of view that you will do continuous integration and continuous deployment. What if
Mhm.
you consider that there is no deployment, no development required for your product?
Yeah.
In that kind of a scenario, do you
Okay.
still need such an architecture?
Yeah. I think it's a very good question. Means when we are looking at the business goal of an application product development, right? Uh, so why do we get into the development? When you have a new requirement to fulfill, correct? When you have a requirement to fulfill, we go for development, right? We
Yes.
develop that feature, correct?
Yes.
And when we are developing that feature, what do? We develop that feature and package it, make it as a var jar, right? um, and means it's just like, okay, we do a build, and when we do the build, that holds the dependencies. And if you look at the traditional softwares which are still traditional today, and the libraries are so tightly coupled with the application that you cannot detach. And on the operating system, it look it as a Java runtime, right? Or JVM. But when you look at on the application dependencies, these libraries and these functions are tightly coupled, and there is hardly a new feature you are adding, and that is restricting you not to do continuous development. When you're not doing continuous development, it is okay to keep it in a VM. And the best example is a database, right? I don't see database softwares are being continuously developed unless it is a new form of the database. Anyone wants to add um, or or something which is means I would put it in this way, where there is no continuous demand for features, then the development is less. And when there is no continuous development, you make only one release once in a year, or some companies I know, okay, they do a release in once in 3 years, right? So in those cases, you need not go for this kind of architecture. Did you get an answer?
Yeah.
Did you
And
get, you know
and
so
the second.
yeah, you have a follow-up question?
No, there were two questions actually.
Can you repeat that? Might be I lost the track of the second question.
Yeah. See, okay, both these questions actually come from a basic idea. What you are basically doing is you have one application, you are splitting into parts, and then try to develop each part. Then, in the process, create a mechanism by which all these parts communicate with each other.
Yeah, and why do I do that?
Yeah.
Why
So,
why do
so
I break the application into several parts? Okay. uh, and not I'll show.
yeah. So let me complete.
Hmm.
And end of the day, what you're trying to do is you try to create a container which ultimately captures all those things. And whatever you have taken apart, it ultimately creates a baked image out of it, right? So I'm thinking, if you think of a scenario where you think that, yeah, my development is done, And especially when you have systems where you actually generate VMs on a minute or second basis. And why you actually get into that container? Scrap it. And
Yeah. So
that's how the thought came. That's how the thought came. So the second
yeah.
question
So
is,
so
I mean,
so
you should
so
not
again, first
systematically
first let
change
me
that.
clarify that you are not baking all the features into a container. Okay, you're taking a function and means developing a service container versus developing an application container, right? So when you are looking at large applications, you cannot have all the features developed into one container. Means one application. It has to be multiple services. So that is the first thing which you need to get your understanding clear in the development. Whoever is the developer. Then this second one is, why cannot I stay with virtual machine and I will get the virtual machines timely within minutes? Then why cannot I stay? Yes, you
Yeah.
should stay, uh, provided your environment, the trust of the environment, because there also you need to ensure the reliability, stability, scalability, and all that, right? So if that environment automated through infrastructure as a code, and you are ensuring that your end customer is getting the services on time, then you can continue to stay, and your development is not happening so frequently, like 10 deployments in a day, or 50 deployments in a day. Means 50 changes you are not reflecting. So in those cases, you can continue to stay on your VM environment. No one is stopping you, and that kind of application will still coexist. Okay.
Again,
then
just a, yep, sorry, go ahead.
then the third thing which I wanted to talk about is, uh, and this is my favorite, right? But always understand, okay, why is there the business reason of change, right? You have been doing certain things pretty nicely. Why do you need to change, right? uh, so understand that when I'm doing a release, all of you understand the definition of a release, right? Every application goes through the development, QA, staging, UAT, production, then service exposed to the end user, right? And where and what is the principle of doing the version management is your SCM, right? So when you have this kind of structure, obviously you have to go through all that, right? Once you will go for automated testing to reduce the time it takes to test. You will go for continuous integration to reduce the rebuild of the infrastructure, right? Once the application, you will go for environment equivalence through infrastructure as a code. That means you're transitioning from development to QA to staging, UAT, and production. It doesn't take time because your environments are getting created quicker and faster. I have seen organizations take 3 months to develop and build one environment. 3 months it takes to build one environment. So if you want to reduce the time, you have not only done changes in the developer's code, right? Developer's code, yes, I think the developer is pretty clear how he or she is developing with those qualities of development. But as an organization, from the business standpoint, you are also not skipping these four environments. You are also not skipping the 5 steps of deployment, right? Then the last phase comes into the every environment you have to deploy. Okay, and the deployment should not be an outage because you're replacing a software with another software, right? And it should not be an outage, right? Why companies do not prefer to go for continuous changes into the application? Because after they make the change, the build happened, the test happened, and you want to do the deployment, and there when the change happens, it takes time, right? Even a simple website, I remember one of my colleague was saying that, okay, I would take minimum 30 minutes to change because he has to build the links and all that, right? So in those kind of scenarios, you have to automate your deployment, and those deployment automation where those changes are being automated, and it has to be zero touch, right? So you have got blue-green deployment, canary deployment. So here, what I'm talking about is the canary deployment. Okay. Here, what I'm talking about is the canary deployment. And if you are talking about the canary deployment, then what you are, getting the outcome in this is when the code is, moving from development to QA to, every time it is getting deployed. Okay. And it comes to the production. It comes to the production. And this particular production deployment is expected to do the change replacement, right? The change replacement. And when this change replacement is being done, you would be continuously pushing the load, so that means it is becoming bigger, and at one point you are so here you are actually pushing the deployment not to the whole customer base but to a segment of the customer base. Okay, that segment of the customer base is actually testing it continuously. It could be your internal employees, right? The canary deployments are preferred to be done in a set of customers, not with the whole customer base, right? So that way this change can still be tested, and it can be tested in such a way that you have less impact, or very little impact with respect to your application change, right? Whereas in the blue-green deployment, you maintain two production environments. Okay, you maintain two production environment, and the products, I don't have an example of blue-green deployment, but I will show it sometime. But just think that, okay, you, instead of this yellow stuff, you have a blue production and green production, right? And any Kubernetes guy will say that, okay, I will use a label. Okay, I will point my service route, right, to that particular label. So at one time, I will be pointing to blue. That means blue becomes my production, and green becomes my last newly developed deployment. And I will change that to the green. Okay, when I'm switching, the green one becomes the new production and blue becomes the old this thing. And if it fails, you just switch over, right? So that kind of pipeline also you can develop, and that is also doable in the organization. So deployment plays a significant role, okay, apart from the other improvements you bring to make the microservice development from the business standpoint, how you implement in your organization. I'll just pause here and I will expect any questions. And we will see all that demo. So those who are still with us, you would see that demo. Then I was also talking about when you are creating a service, right? So ideal scenario, the Kubernetes service, what it does is it distribute in a round robin, right? So it distribute the traffic 50% to version 1, 50% to version 2, right? That is what it happens in an ideal scenario, right? So it distribute the traffic to your first service, then to the second service. But where is it becoming the change? The change is, why do I need to put 50% to the new pod, right? Why can't I give 10%, right? why can't it be browser specific? Why can't it be region specific? For example, I'm pushing a new change, and that is for a specific country or continent, right? So for a specific set of IPs. So why can't I change that? So if you want to change that kind of pattern, then this is a canary with Istio, right? So we discussed what is the difference between a blue green and canary, and why did I prefer canary for Istio is because it goes to a specific set of users to see the new version of the code or version of the service. So that way the 10% is receiving the new version and 90% are still on the old version, right? And that kind of change companies prefer to do in nowadays because they continuously bring new services to life. Okay. And to do this, the first thing I said is the cultural change. Accept that I can still afford to push the release to a lesser populated population, or it could be my internal employees, okay, to see that change. And it should be self-service, it should be on demand, it should be elastic infrastructure as a code. Then you have to really stand tall in your organization, because organization politics are like, okay, you will have 40 members in a development project, right? And you must be having several discussions happening there. So if you want to have a smaller team, then it should be a pizza team, right? Means pizza depends the size in India and US. Okay, in US it's about 8 people, or in India about 4. So your project team, your application service team, which is actually developing applications, should be self-sufficient enough to take a decision to push the release for that particular service, rather taking a consent of 40-member team, right? So that's a cultural change. And automation, DevOps, self-service, on-demand, elasticity, CI/CD, deployment pipeline, all that you need to bring to life, okay, when you are getting into these kind of culture, business requirement changes. I'll just pause here, and this is a more thought leadership topic, that okay, why the release process have to be looked at differently than it is being traditionally. And don't just blame your developer that okay, he should be focusing on microservice development. It is a whole lot of change, okay, which you need to bring if you want microservice architecture to be really brought onto the life. So with this, I would now switch to the demo, right? And I will take the questions. Are we good, Chandra?
Yep. I just wanted to give my 2 cents on
Yeah.
Gagan's question as well. So Gagan, my thought process is, so a lot of whatever Deepak has talked about, we're not saying is not possible on a monolithic service as well, right? Monolithic architecture. It is possible, people do it, but it's about the operational complexity that comes with trying to achieve those. So uh, my argument here is, if you go back to the definition of microservice, which is essentially having multiple services, uh, multiple isolated services which are capable of talking to each other. If you feel you have an application where having that kind of a framework where you're using network-based communication to talk to each other is overtly complex, or if you have a dependency with the file system like Deepak was mentioning, which cannot be overcome or would take too much of effort to actually uh, recode or re-architect or refactor, then it makes sense to stick with a monolithic architecture. Whatever Deepak has talked about with respect to the deployment can be achieved on a monolithic architecture as well. It just boils down to how complex it becomes. In a with a framework like Kubernetes, it's simpler. in a framework where you are just using bare metal or virtual machines, it gets overly complex.
Yeah, and please note that okay, when you are doing Canary deployment on monolithic, I'm not saying that okay, means I'm saying in microservice it is preferred over the monolithic blue green deployments because you can make the change reflect to a specific section or specific segment of your customer with just a change in the approach. Okay, so we will get into the demo.
Thanks, Deepak. Let me just quickly share my screen.
Sure.
Okay, is my screen visible?
Yeah.
Okay.
Okay, so if you can give the audience little requirement, things like if they need to perform this at home, what they should do.
Yes, before I sort of get into that, I wanted to probably spend some time to explain the architecture of what we're trying to deploy. Yes, that is one of the things I'll also discuss. Is my screen visible? Do you guys see a Jamboard?
Yes, yeah, it's visible.
Okay, great. So I've not done this, so probably there will be some hiccups, but let's see how how well I'll be able to explain it with this. Okay. So do I have a shape circle? Okay, let's go with a circle. Okay, so is anybody in the audience familiar with the concept of MVC, Model View Controller? Okay, no issues. So the MVC architecture that you hear most developers sort of throw around, flail around quite a bit, very frivolously, is something very inherent to how a, uh, an application is designed at the end of the day, right? The thought process is quite straightforward. You have a model, a view, and a controller. So a view is essentially what the end user ends up actually seeing with on their screen. So it can be either a web application or it can be a desktop application. Whatever the end user actually ends up seeing is the view part of the application. Then you have the controller, which is the brain, which is responsible for actually sort of being like the middleman between this view, and then there's another concept called model, which I'll get into. So you have a middleman sitting there, which is actually responsible for balancing the requests and the sort of information that it receives from the view itself. And then finally you have the model, which is the horse of the overall architecture, which is responsible for getting the information from the controller, which the view passes on, and then actually performing the overall computation on that, and then it sends it back to the view. So these are the three moving parts that you typically have with every three-tier architecture application or any web application that you guys usually see. And the beauty of microservices is it becomes really easy to actually implement this because each one of the microservices that you have can actually be one of those components. And I have a similar setup with me as well. I'll get into. But in terms of this architecture, are there any questions? And you might just ask me, okay, Chandra, why do we even need all that, right? Why don't we just have everything in a model view controller? It's about again, going back to Gagan's question, right? It's about the philosophy you want to adopt. It's about what we feel is the current best way of solving a problem. So MVC happens to be one of those things. It's long-standing. It's an enterprise architecture which is followed throughout. So And whatever benefits Deepak was talking about, a microservice obviously applies here as well. So that is the reason for the adoption of this architecture, this development architecture. And like I said, it becomes easy when you have these as independent microservices. Any questions with this particular setup? Model. Sorry, this view. Shift that here. 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 And then finally, you have the controller, which is the middleman. Okay. All right. So this particular setup is something quite popular. It's pretty easy to implement yourself. Folks who have laptops, which I'm sure all of you do, you just have to install something called Minishift, which is like a single node OpenShift, and that can be installed on your Linux or Windows or Mac machine. So you can just go ahead and do the installation of that, and I'll share across a GitHub link which you can actually utilize to try to do to emulate what demo I'm going to show to you guys as well, and see for yourself how it works end to end. Okay, so like I said, we are following a similar architecture in our demo as well. We have a view, a controller, and a model. Your view actually, in our case, is a Spring Boot application with very minimal dependencies. So dependencies here being the Jaeger, dependencies that I'll probably talk about a little bit once we actually get to that. And I have my controller, which is again one more regular Spring Boot application, and again has certain dependencies with Kubernetes related frameworks like Jaeger. And then I finally have my model, which is basically a Vertex application. It contains some handlers and a few dependencies to work with the overall Kubernetes architecture. So let me just go ahead and name those. So I have my front-end application or front-end API, which is the customer application. I have my controller, which is the preference application, and these are all names, right? What you see here, these are just names that we've given to the application. MVC that you see in the circles is the actual architecture. The names that I'm populating below are the names of the microservices that I've created. So customer preference, and the final one is recommendation, which actually is the workhorse of the overall application. So these are my three microservices which are currently sitting in my OpenShift environment, and this is where we'll show up how usually this Canary deployment works, right? Any questions so far?
Nothing from my end, Chandra.
Okay, all right. So now, like I previously mentioned as well, a lot of this can actually be emulated in a monolithic environment or a non-Kubernetes or OpenShift environment as well. It's quite simple to, it's not simple in the sense it's something that, you can do from the get-go, like with Kubernetes or OpenShift, but the overall fundamental way of doing it is also quite similar. It just so happens the operational complexity is quite high. So with a Canary deployment, like Deepak was mentioning, what usually happens is one of these microservices that you see, or one of these applications that you see, actually has a new version that's deployed alongside. So for example, in our case, we have a recommendation application, the model, which has a new version that we've deployed. And the third process is we want some of the customers to test it, right? So let me just go ahead and name that module and just call that. recommendation V2. This one, recommendation V1. So we want a certain subset of our customers to actually end up using the recommendation version 1, and a certain subset of our customers to use recommendation V2 based on certain decisions that we take, right? So now, if I had to go perform this in a non-Kubernetes environment, the way I could probably achieve this is either at the controller, I will build some sort of logic which says, okay, based on this certain headers. I hope people understand what I mean by headers here. These are HTTP headers that come alongside. If probably you need more clarity, I'll probably explain that as well. Based on certain headers, you please route the request to recommendation V2. And if those headers are not present, please route it back to recommendation V1. So I can have some sort of coding logic that is actually present in my controller to enable that. That is one way of approaching the problem. The second way of approaching the problem is, let me have a load balancer sitting here in the middle, and let me have some sort of logic sitting there, something very similar, where I will have based on certain headers. For example, the user agent. If you guys know what a user agent header is, it basically determines what kind of operating system is actually present in the client environment. So, for example, the browser that's being used, is it Safari, is it Firefox, is it Chrome, or the the operating system version that's being used, whether it's Mac, whether it's Windows. So based on certain header policies like those, please accordingly route the request to recommendation version 1 or recommendation version 2. So you can have some sort of routing logic sitting either at the controller level or sitting either at the load balancer level, which is between my controller and my model. So that is one way of approaching the problem in a non-Kubernetes environment, where you can have that sort of policy set in place to actually perform that routing. So uh, uh, you know the obvious problem with that is the fact that you're actually going to the controller level and modifying a piece of code there, which might not be useful somewhere down the line. Obviously, once you are completely comfortable with the recommendation engine, you would immediately want that to become the norm. So again, you'll have to go and make some modification at the controller level to make that happen. So that's completely out of question. Then you have this load balancer concept where you can just use a certain header policy to route the request. So you'll just make a modification over there. But then there's this additional overhead of actually managing that load balancer, uh, creating those routing policies over there, and having a real expert sitting who's capable of managing and maintaining it. So that's one more operational overhead to keep in mind if you go with this. So that is the obvious problem with trying to achieve something like that. Any questions with this, or any better ways of probably approaching the problem?
Yeah, Chandra. For the model recommendation V2, do we need to have more VMs in place to accommodate the new version or the new GUI which is in place? I mean, like new
So
additional HTTP servers. Yeah.
yeah, so that's a scaling problem. So obviously, if you feel, for example, you'll be routing, obviously. So the recommendation V1 and V2 will be maintained as separate VMs. I'm not saying that has to always be the norm. Again, that can be bypassed. You can have the same application sitting on a single virtual machine, but you'll change the port, right? So that is also possible. But ideally speaking, you should be having a separate virtual machine to house your version 2 of the recommendation engine. And obviously, based on the load that you get, the thought process is you have to make a judgment call there. So one thing is maintaining a separate VMs, which I've answered, but one more question is the scaling issue, right? How
Yeah.
many VMs do I actually house for my version 2 recommendation? So that becomes a scaling problem. So for example, if you knew 10 VMs were being used previously, and now you have this version 2 recommendation engine that's come into the equation, you will say, okay, let 8 VMs house my V1, let two VMs house my V2, right? So
Great.
that kind of judgment call you'll have to make, and that's based on your own application history. You can sort of make that judgment call, right? So you can have that in place. Obviously, if that's something that's too much of a burden, you can house your same recommendation engine on a different port, and just at the LB level, instead of pointing it to port X, which is what the port was being used by recommendation v1, you'll map it to port Y.
Okay, the load balancer we are using is a traditional application load balancer, or
Yeah, so you will obviously use a software load balancer, because it doesn't make sense to put a hardware load balancer there, right? That's
yeah,
a nuclear bomb to a
yeah, yeah,
you
yeah.
know a solution to a seemingly simple problem. So you can use something like HA proxy Nginx,
It's a
and
proxy.
the complexity, obviously. I mean, so it all depends, right? What kind of routing policies you want to set in place. The complexity depends on that. But usually, you can have like a 90-10 rule or something along those lines
Yeah,
to sort of route the request there. But the when we go into specific use cases, like say for example, routing all the Safari users, which is what we're going to showcase in the demo, to recommendation v2 and mapping everybody else to recommendation v1, that becomes significantly more of a challenge in this LB, right? To
yeah,
actually have those routing policies set in place there. And
yeah,
the complexity also arises when you have multiple deployments, not just one. So here it's just version 1, version 2. If you have 5, 6 versions, then the complexity of maintaining the load balancing rules there becomes even more, right? So all these operational challenges are there, and as a architect, when you sit down, you might just think, okay, just having an LB there will solve the issue. But once you actually get down on the field and start implementing these, that's when the challenges actually come to your light, and that's where you end up facing the issues. So as a standard, what we usually do is we try to and getting a bit philosophical here, but the as a standard, you always try to uh, push across the complexity to somebody else, right?
yeah.
You don't want to house it yourself. So that is what I'm going to showcase in the demo itself. In this case, obviously, you're having the owners of the complexity, but in the demo, where we have Istio being used, the complexity lies with Istio to maintain all of that. And again, it's all IP table rules at the end of the day, but somebody else is writing them, right?
Yeah, great. Thank you.
Good question, though. Any other questions? Deepak, is this so I have had limited experience with Monolith. We obviously do a lot of transformation, but is this usually the kind of things that you see in the enterprise? This is from my experience, but are there any other methodologies that people use to perform these kind of operations?
Yep. I think to answer it in a better way, means yes, most of the time when the enterprise workload increases, um, you got the question, right? Okay, do I need to increase the capacity
Right.
of the machines, right?
Right.
That is what comes into the discussion, because everything is related to the compute, capacity and the scale. Right? But in microservice, it is pretty much sorted. So
Yep.
can you get into the
Yep.
demo?
Sure. So in the obvious microservice environment, rather than having a load balance or anything sitting in between, you have the overlay network, which is taking care of all the complexity here. So that would be the actual Istio engine, which uses the Envoy proxy and all as a sidecar container in all the deployments, and that creates something called a virtual service, which is responsible for balancing the request between your the models that you have. So it actually takes care of that complexity that I was referring to, where you have to have some sort of logic sitting here to perform the request. So it takes care of all that complexity. And each of these, like I mentioned, is deployed as an individual microservice in my OpenShift environment. Let me just head over there. Let me do a quick tutorial record. Okay, so you can see my microservices here. Obviously, there's multiple deployments. Uh, you have the customer, which is the view. You have the preference, which is the controller, and then you have the recommendation, which is essentially the model. And we have two versions deployed, version 1 and version 2. And at this point of time, we currently have a virtual service already running, which is going to balance the request between these both these versions. So just a second. So if you see, I have a 50-50 load balancing that's happening here, where some of the requests are going to version 1, some of these are going to version 2. Now, like Deepak has mentioned, it is possible to achieve this even without Istio. You could just have labels sitting in between, or you could have something similar to what I've just explained, where you have a load balancer sitting in between, which will do that routing for you. But at this point of time, it's a 50-50 request load balancing that's happening. Okay, so let's start generating some load now to this, and let's actually see how you can perform the tracing and the monitoring of this. So okay, so as you can see, now I've started generating some load. The script is pretty straightforward. It's just doing a curl request each time to this particular customer endpoint, and that's starting to generate some load. Let's head over to our Grafana and see what's actually happening here. Do a reload. Okay. So let me open my Grafana. Okay. So if you can see here, I'm able to see the actual requests that have been generated. Again, like Deepak mentioned, nothing special happening here. This is still an OpenShift function. These things come off the, off the shelf for you. You can see the services that are associated with my particular, application, which is recommendation. I can see the success rate. I can see everything is prim and proper. I have no issues so far at all with the overall success rate or the requests that have to come back. My pings are still going on, no issues there. Let me head over to tracing. Let's see how that looks like. I'm going to stop this and let me open Jaeger. Okay. So folks who've just seen all of this, right? Jaeger is basically a tracing tool. This was something that Uber actually released as an open source component. This again is native to Istio and the frameworks that come with it. So this allows you to actually see the tracing requests that are being generated by our customer service, right? So let me just find those traces. Okay, so you can see individual endpoint hits that are coming to my particular customer application. So each one of this is a single, it's a single endpoint request or a hit. That means it's a single curl call, and you can actually see the amount of time it's taking to respond to all of those as well. So all the traffic that I'm generating is now, it can now be visualized using this particular tool. So this is one more component of tracing. Now, you might ask me, okay, Chandra, this looks very pretty, right? but what am I actually getting out of this, right? Uh, any developers in the mix here? Okay, so I'll wear the developer hat. So uh, you know, when you're talking about resiliency of your application, when you're talking about pinpointing exact errors, uh, it becomes difficult to sift through logs and pinpoint exactly which call is facing an issue or exactly which endpoint is request has gone for a toss, right? Uh, in enterprise, when you are dealing with production workloads, as a developer, you do not get access to anything. Some of our customers, even the operational folks at the end of the day, they don't have access to their own clusters, right? It's all managed through automation. So getting the perspective on which call is failing, which is not failing, which one is working, and trying to understand, why it has failed, that becomes quite a bit of a challenge. Now you have stuff like ELK in the mix where you can do some sort of digging, but then you'll have to become an ELK expert to actually make that happen. And tomorrow there'll be some other tool which comes into the mix that that your organization would like to adopt, and suddenly you have to become an expert at that, right? So tools like this, where you're actually able to pinpoint individual requests that are being made, they actually make a developer's life quite simple, right? They can just understand, okay, at what time, what call has been made. They can actually, if you guys are familiar with Chrome network tools, you would know that, okay, getting this kind of granularity is good, but in order to emulate this, the pains that go into trying to emulate that are significant. So when you're getting these kind of results off the shelf, it makes your life extremely simple, right? So that is what Jaeger brings into the table: the distributed tracing and its ability to provide this kind of timelines, right? That adds a lot of value to a developer's debugging, capabilities. So this is one more aspect of a service mesh, which really makes a life simple. Yeah,
So,
Gagan.
so yeah. So Chandra, the demonstration that you gave has two microservices. Is my understanding correct?
It has the Gagan. It has three.
You the view model and see the same framework you're using.
Correct. I'm using the view model controller. So going back to my terminal, and let me do a kubectl get pods. And while that loads, okay. So I have three microservices: customer, preference, recommendation. Customer is the view, preference is the controller, recommendation is the model. So we are emulating a scenario where we have released a new version of recommendation, and we are seeing how the requests are being, um, being distributed among these. So the reason why you see customer there is because at the end of the day, customer is what the
No,
yeah.
no. So Chandra, the additional thing that the tool or framework that we are using is giving us, the introduction of recommendation V2 is very easy. Do I understand that part correctly?
So this particular tool, Gagan, when I say this particular tool, I'm talking specific to Jaeger,
No,
is
no.
not
Okay.
about.
No. Your basic thing is you had scenario A.
Mhm,
In scenario B, you have introduced a version 2, right?
mhm, mhm. Yep. So
Huh.
we've jumped to scenario two. We've not showcased scenario one as such, because if you see the curl requests that are coming, they're going to both one and two. You're not having a scenario one where we're only displaying things hitting version one. So at this point of time, when I'm making the request, it's being load
Okay,
balanced
okay, okay,
appropriately to both of
okay.
them.
So no, I thought you wanted to establish it is easy to introduce the V2 complexity, version 2 complexity, and then so that how things are automatically running in a straightforward way. Yeah, but I got you. So you are now showing the scenario 2 and saying what are the additional built-in components into here.
Correct.
The one question is, so in this particular case, when the way you are defining microservices, items communicate among each other, right?
Mm-hmm, mm-hmm.
So here your communication till the customer point, I mean customer and then the model. Till the model point, it is pretty straightforward. After that, it is splitting, right?
Yep, yep, correct.
And that split in your first scenario, that split you said you have achieved by doing so many things, a load balancer or something else, something else.
Right.
In this case, how are you achieving it?
So in this case, it's through a concept called virtual service, which is again, it's like you can think of it as an overlay for your overlay. Your overlay one being the Kubernetes environment, your overlay two being the Istio that is coming into the table, right?
You
So
can say that, okay, you're using STO.
Yeah. So the concept of sidecar is this. You are saying you have a basic concept, basic thing running, and then you are putting a side there. Is that what you're trying to establish?
yeah,
I
so
mean, I mean, the version 2 is coming into picture through the sidecar functionality of LSTO. Do I understand it correctly?
yes, so that is obviously the overall end. So you have your controller, which has that envoy side proxy container that we're talking about. So that is actually performing that, correct? But I'll get to why, how it can get more increasingly complex, right? Let me get to that part of the demo. For now, I just wanted to showcase uh, what kind of tools are being brought into the equation, which would help a developer actually understand, uh, you know, how to backtrack a certain particular error and certain particular test scenario that he's probably overlooked. So uh, the overall complexity of this, how it absorbs that complexity. I'll get to that. Does that sound good?
Yeah, it's okay.
Okay, cool. Any questions? Any other questions? Okay, so I have stopped my API calls which are being made to recommendation. Now, let's talk about a complex scenario that we want to achieve, right? So, say I have my STO, which is sort of managing all of this. Say I want a scenario where I know that I want recommendation V1 to be the one that everybody ends up using, except a small subset of users who you would want them to continue using Safari, who you would want them to start using recommendation V2, right? And that particular subset is the people who are using Safari. So the problem statement is whatever requests come, let that be automatically balanced to my load balance to my model, unless it's a Safari user. If it's a Safari user, please route that request to recommendation V2. So this is where the actual complexity starts to crop in, right? You can have a load balancer sitting in between, like I mentioned, which does this 50-50 load balancing. Even at the Kubernetes level, that's, I wouldn't say it's very difficult to achieve. But in these kind of specific scenarios where I just need a certain routing policy in place, achieving that is where the problem starts to crop in. Uh, Now, all that is actually just absorbed by Istio as a framework. And let me show you how simple it is. So all I'm going to do is I'm going to run two commands. The commands are just going to, just a second. Okay. So the commands are just going to make a small modification to this virtual service to actually load balance the requests that are coming to my recommendation engine, based on which it starts balancing those requests to the V2. So I have given a scenario now where all the requests that are coming to Safari should only be V2 requests. So let's run my script again. So V1, V2 now is the same, right? Because I have not put a policy for V1, V2 or the standard scenario. So any requests that come at this point of time are still being managed between V1 and V2. But whatever requests now come through Safari, those need to only be V2, right? So V1, V2 here is the approach, but let's open Safari here and let's start checking the requests that are going to come. Okay, I can still see that my recommendations are not being load balanced appropriately. Let me deploy.
Chandra, I think now it is showing V2 from your Safari.
It is showing V2. Yes. Yep.
Okay.
Okay, so the reason why this is happening is there's one deployment, if you can see, which is my 6567. So that has also cropped into my existing virtual service. But all the other requests that you're seeing are all my V2 requests. So my 65 CD, which is the new version 2 deployment, that has been incorporated. I think the script that I have deployed, essentially that has incorporated V1 as a new deployment as well, and that is why it is considering that as well when it's actually going and hitting my Safari, when it's actually going hitting
If
my
you do a get
Safari.
pods, you can show how many.
Yeah. Okay. So
You
if you
have these
see here,
many services,
yeah.
the servers, which is
So let me maybe show you a different scenario. Let's set all my recommendations to V1. And let's okay. So slight change of use case that we're trying to showcase. So now you can see I have my V1 and V2 running. Let's confirm that. Okay. So I have both V1 and V2 running. If you could see earlier, the load balancing that was happening was 50-50, and the requests that were coming, they were being balanced between the both of them. I have applied a virtual service, which is essentially, you can think of it as a very basic IP table rule that's being implemented, which is routing all my requests just to V1. So it's a simple, YAML file script that I've had to inject
yeah.
into
If
my
you go to
existing.
the YAML file, you will find the split written there.
Yeah, just a second. Okay, so these are the labels that
Labels. Yeah.
Deepak is talking about, and if I okay, so you see this weight over here, right? That is essentially representing the percentage of routing that has to happen. So if it becomes 90, for example, 90% go to V1, the other 10% will go to V2. So this is the script that I've applied. And when I'm doing a constant curl, you can see that the requests are only being offloaded across to version 1. And just to reiterate again, this is not complex, right? Somebody has spent some time writing the YAML files, obviously, but you saw how big the end YAML file has boiled down to, right? Now, if I go back to the previous way of approaching this in a monolithic way where you have a load balancer sitting, you can imagine the complexity that actually comes to the equation to achieve something like that, as opposed to a simple YAML file here, which is just modifying the load balancing and taking care of all that complexity. Any questions here? Let me see if I can get the Safari use case also working in the meanwhile. Okay, just a second. Yeah, I can take some questions now while I'm working on this as well. Guys?
Questions, guys? So the next session, we will bring. So Chandra, we can do a circuit breaker scenario also.
Yes, we can, Deepak. I've just got the Safari use case working as well. You can see all my load balancing requests are only going to my version 2. I have nothing going to version 1. But at the same time, if you see, as a standard, the requests that are coming from a normal curl call are all going to version 2.
Fantastic.
Just to prove that as well, let me do a quick curl from here. Okay, so you can see this hyphen A is basically saying user agent, passing that as a parameter, and it is asking my curl to emulate the Safari browser. So when I'm emulating Safari, I'm getting a version 2 request. But if I were to remove this, I would only get version 1.
Yeah. So that's exactly the concept of Canary, right? Okay, you're pushing a particular release to a specific section of the users, including not just a region or a group of people within the organization versus outside the organization. You can also do it at a browser level, right?
Right, right.
Yeah, so that's what we were talking about in the Canary principle, that you are doing things in such a way that it is. I'll just use my slide to explain that. I think okay, we did it, uh, but I'll do one more time. So here you go. Can you see my screen?
Deepak.
Yep.
Okay, cool. And let me present it. I'm sorry. I'll go to the specific slide. Yeah. So Chandra, you explained the purpose of a sidecar and how Istio was orchestrating it. So what you did is you pushed the V2, and this is what V2 you pushed, right? With a very little workload, and then you kept increasing the weight, and it started replacing a percentage of your production user base with the yellow color release, right? So edge, it replaced fully, it became a full production release. So in this case, the benefit is you have not taken a production blue green, rather you took small releases and made that as a complete v2 release. Okay, so this is something which would answer a lot of your questions related to the release mechanism. The other aspect which I also got a question from someone, I think Gagan or somebody was asking, that why should not I So this is what Chandra you have shown 50/50. So by default, when you run in Kubernetes, the HA proxy distribute it in a round robin. But this is what we achieved. Canaries deployment with um, the Istio, right? We also demonstrated um, or we have discussed, right, okay, how the service orchestration work. And in principle what we have agreed is that in a typical scenario where you have um, jumbo teams, and you do not want um, situation like this, right? Where a monolithic system is taking 12 weeks for one release. Even though you have shortened, many people come back and say that, okay, oh, are you saying I cannot do DevOps on the monolithic application? Answer is yes. You have several ways to achieve the you can shorten. What you have done is, okay, you have taken, instead of 12-week one single release, you have done you have split it into several weeks, and you are still achieving the monolithic system new release in a high trust environment, which is an enterprise environment. But you also have cycles, right? Okay, you have cycles of maintenance, so where you will do the bug fix and all that. So you still take about 4 to 7 weeks to get these bug fixes done, right? So the expectation is this 10 deployments a day. That's the basic baseline since last 1 decade. Okay, so if you have to achieve 10 deploys a day, read this book, Phoenix Project. And then that is in practice since 2008 or 9, I would say. So what do they suggest? They break up the monolith into microservices. And those who were asking question, okay, why do I need to have a microservice? This picture would explain. I just pulled it from developers portal. So instead of having one monolith with 10 services, you have got each service. Now can this be done by the same development team? Not necessary. You can make small teams owning the outcome of each service. Okay, and each team can do their own releases. Okay, and it's a trust factor. That is why it is a cultural shift also. And what else is the benefit here? You have built the trust with each team. Each team is a development team. Each team has their own releases, and they can bring things to life quicker and faster, and that is through Canary, what Chandra was showing. So you can have the service improvements felt through in an organization. And we also talked about the complexity of a large Java application. And this is what is the complexity, right? So those who are, still arguing about why should not I stay monolith, you can continue to stay, but you have these dependencies. Okay, and we discussed about these dependencies and the repo creation of this. What is the repo creation of this dependency? You have whole lot of services bundled into a like a snowball application, and you are expecting the transformation to happen, right? So obviously your release cycle will be longer and you will have the changes. But the more to that is when you have different framework, right? Like Chandra was talking about MVC. So if you have different frameworks to support you, right? When you have different frameworks to support, obviously this 43-member team cannot solve your problem, right? You have one team which is using Spring Boot, you have another team is using some other framework. So why can't a service be linked to the best framework which is applicable to that service, rather the entire application is using one single framework. I'm not a developer, but I would ask developers to agree or disagree to this particular thing. So you have split the 43 member into smaller developer teams, and each team may use a different framework to build their service, and all these frameworks are supported on Kubernetes and OpenShift. I think that's another way you must convince your stakeholders or the management why the organization should go for microservice based and canary deployment and progressive releases with zero catastrophic failure, and introduce your Istio to handle those kind of complexities, and it follows all the microservice qualities. So these are the qualities which you should bring. I think we also had a question that, okay, can I have the continues to have a shared database team? Yes, you can. You have to live with that. Okay, but if you want a better result, you should decentralize the governance as well as the database teams. Okay, so with that, I would say that I think we are good so far. So, so what did we achieve? We have achieved that our journey to microservice has been, reorg the DevOps, self-service infrastructure, make sure that infrastructure as a code is practiced. Then automation through Ansible. You saw Chandra was using the Ansible YAML, okay, for Kubernetes or OpenShift, and use CI/CD deployment pipeline so that it can be achieved zero touch, okay, and use Canary, that is an advanced deployment technique with Istio. Then you can be the SiliconValley.com startup, right? So with this, I would end today's session. We are top of the hour. Thanks for joining and being part of the discussion. Please post your comments and questions on the chat, or do send a note to the organizer.